The pressure on address space usage spurred the adoption of Classless Interdomain routing, or CIDR, which was adopted in 1994. The idea is that instead of having fixed network ID and host ID portions of the 32 bits, instead we would simply have an IP address and what is known as a mask, where the mask is variable length and indicates the length of the network ID. So for example, suppose we have an IP address like 65.14.248.0/22. Well, in this case, our 32 bits look like so, but this doesn't tell us how long the network ID and how long the host ID should be. The /22 indicates the mask length, which says that the first 22 bits should represent the network ID. Now the key is that this mask can be variable length, and the mask length no longer depends on the range of IP addresses that are being used. This allows those allocating IP address ranges to both allocate a range that's more fitting to the size of the network and also not have to be constrained about how big the network ID should be depending on where in the IP address space the prefix is being allocated from. Of course, now the complication is that it's possible to have overlapping address prefixes. For example, 65.14.248.0/24 overlaps with 65.14.248.0/22. The red prefix is actually a subset of the black one. So supposing these two entries both show up in an internet routing table, what are we supposed to do? The solution is actually to forward on what's called the longest prefix match, meaning that if a routing table has two overlapping entries, that it should forward according to the entry that has the longest prefix or the longest mask length. Intuitively, that makes sense because the prefix with the longer mask length is more specific than the prefix with the shorter mask or the larger prefix.